Hey guys, this is Leetcode problem number 347, top K elements. First I'm going to go over the problem, then I'm going to go over the implementation, and then I'm going to go over the code. So let's take a look at the problem. The problem basically says that you're given a non-empty array of integers. You have to return the K most frequent elements. And they're also saying that you have to do this in a time complexity that's better than n log n. We're going to take a look at an example that actually looks like that, but then we'll try to top that. And it's saying that every single one of the answers is unique. So basically they're saying that all the integers within the set that they give you is going to be unique. So let's go ahead and take a look. So one way you can do this is actually going to end up being n log n time, but we're just going to take a look at the solution, is by sorting this list. And technically this is already sorted, but if we were to sort this list, we just go through it and basically count how many of these that we see, right? And then since they're going to be side by side, we just keep a count of this. So it's like 1, it's going to be 3 of these, 2, it's going to be 2 of those, 3, there's going to be 1 of those. And then basically at the end, we return how many Ks we want. So while you're going through this, you would kind of keep like either a list or a couple of integers or something to try to keep value of the top K or however many they ask you. That can be done in n log n time, just because one, the sorting in Java takes n log n time in best case, right? Another way you can do this in n log n time is by using a combination of a hash map and a heap, and that kind of looks like this. So as you're running through the list, this is going to be our hash map. So as you're running through the list, right? So here we have 1, 1, 1, 2, 2, 3. So as you're running through this list, you basically insert the values into the hash map, and you're just going to count how many times you see them, right? There. So we've done that. Now, once you're done, you basically would go ahead and insert these into a heap. But the comparison here for the heap, usually the comparison is like a value between like an integer minus integer, and then it will tell the heap how to sort it. But the comparison that you're going to do here is the values of these key values. So basically what you're going to be doing is something like map.get a minus map.get b. That'll let the heap sort it by grabbing the value of the first thing that you're comparing and grabbing the value of the second thing you're comparing. And it'll basically let the heap sort out the list for you. So the way you're going to do this is first build the hash map and then input all these things into the heap, right? You're going to be inserting each key into the heap, and the heap's going to be using the value, which is how many times that you've seen the thing so far, into the heap. And that's going to take n log n time. The reason why it takes n log n time is because a heap insert takes log n time. And you're going to be doing this n times. So you end up having n log n, right? Because this is the size of your list, right? There is a way that we can make this faster that it actually goes better than this time. And that is the actual right solution to this problem. What we can do is basically do the same thing as we have here. But instead of having the heap ingest every single one of these values, we can actually just stop when we get to a K value. So instead of keeping every single one of these values, we only need the top K. So if we keep a min heap is basically a heap that organizes itself on minimum values. So if you had the list like 1, 2, 3, right? A min heap would kind of look like this, right? Whereas a max heap would look like this, right? So the max heap would have the max value at the top, whereas a min heap would have the min value at the top. Right, so if we do our comparison in such a way that we try to structure it as a min heap, we can basically guarantee that we'll have the minimum values at the top, right? So if we go through this list and we insert this, so first we insert 1, right? So one's the only thing in the heap so far, so that's going to be at the top. That's going to be the root. And then we insert 2. So now 2 occurs less than 1 does. So 2 will now be the root because this is a min heap. And now 3 is here, and 3 will now be the root. Sorry, this is supposed to be a 3. Or, sorry, this is supposed to be a 1 here. So now 3 becomes the root, and it will run heapify again, and it'll do that. Right? So again, these are comparing values based on what you have inside the hash map. Don't look at it as in like which integer is bigger. It's based on like the values of how many times you've seen this. So now this is a min heap based on how many times you've seen it, and the minimum value is at the top. So say if we were just looking for like the top 2 values, right? So now we know that this heap size is bigger than 2. So we just eject the root, or we just take out the root, which is the minimum value of the size of the heap. So if this size is equal to 3, and we're looking for k is equal to 2, we're only looking for the top 2, right? But the size of this heap is more than 2. We basically take out the minimum, the smallest value, because we don't need that. So now we eject the top, and now we're left with 2 and 1, right? After. So that's basically the algorithm. We just go through the hash map after we've basically found out how many times each integer repeats, and then we will insert that into our heap, making sure the heap is less than the k value or equal to that value. Anytime the heap goes over k is the value that they're giving to you, like how many integers you want, we basically take out the minimum value, which is going to be the root. And that will guarantee, as you're going through the heap, that by the end of it, every single value that you have is the largest. Because the largest values are going to be at the leaf nodes rather than being at the top. So that's basically the algorithm. Let's walk through the code really quickly. So I've already started writing the code here. As you'll notice that I've already declared my hash map up top right here. I'm also have created a comparator class right here, and I've created a compare function, compare method right here, right? So it's actually really useful to understand how this works, because you're going to be using that a decent amount if you ever use a heap, or if you ever want to sort your array using the default sorting algorithm that Java has to offer. Basically, we're just grabbing the value here, map.get. So we're returning map.get a minus map.get b, and we're basically just comparing like a integer. The way that the comparison kind of works is it returns either a +1, -1, or 0 based on what the value is. You can go more in depth by looking up some of the Java utils and everything, but I'm going to continue writing the code here. So now that we have the comparison and we have our map up top, we're just going to continue writing the code. And so the first thing we want to do is create our heap. So in Java, I pretty much use a priority queue. So here's a priority queue, and then the thing that we're going to be giving it is an integer. I'm just going to be calling it a heap. And the new priority queue. Here, just give it an integer value. But noticeably here, you need to do a new, inside the initialization, you need to do new heap compare. That's what I called my class for the heap compare, for the comparative function. So if you go up, That's what this is called right here. I'm basically just initializing in here, so telling the priority queue to use that to compare the values when I insert them. So now what we're going to be doing first is going through the nums list and basically just adding it to the map, so that we have how many times each one of these things occurs. So nums.length, and then I++, incrementing, and then just going to do if map.get I nums I does not equal null. So if that value already exists in the hash map, we're basically just going to increment it. So sorry, it's supposed to be map.put, not map.get. This is the value here. It's going to be nums I, and we're just doing map.get. I'm going to run out of space here, so I'll just do map.get nums I +1. Right, so that's what happens when you already have it. Else, we're just going to add it to the map. So map.put nums I, and then we're going to start off with 1. So now that we have all of our stuff inside the map, what we're going to be basically doing is going through the map that we have created and adding that into the heap. So we're going to do if or for loop, and then we're going to do int n for map.keyset. Basically what this is going to do is grab us the keys from the hash map, and we're just going to iterate through it. And we're going to add it to the heap. Offer that value into the hash map, or into the heap. And then this is where we check to see if the size of the heap is greater than what we're asking for in terms of how many integers they're asking for, right? If it's greater than that, then we're gonna take out the top, or the root, which is what heap.pull will do for us. And that's pretty much it. Now all you have to do is create your return array. So here, I like to call my return array return R. Gonna create int. Sorry, new int. K. We're gonna make it the size K because that's how many things we're returning, right? And then just going through, we're just gonna loop through then return R dot length and I++. And basically what we're going to be doing is just taking the thing from return R, taking the thing from the heap. We're going to be taking out the root and just throwing it into the array. And then we just return the array at the end. And that's it. That's pretty much the code. Hopefully you guys understood what I was talking about here and what the implementation is, and hopefully you understood.